Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Slice of Balance, and it's a YY sandwich puzzle, which is yin-yang sandwich, and it's by Puzzle Tank. And here are the rules. We have normal Sudoku rules, where we need to place the digits 1 through 9 in each row, column, and 3x3 box. We have crop key dots, where if digits are separated by a white dot, they must be consecutive. So for example, if this were, say, this is 3, this has to be 2 or 4, because these digits must be consecutive with 3. We also have yin-yang shading, where we need to shade some cells such that all shaded cells are orthogonally connected and all unshaded cells are orthogonally connected. So this would be a valid yin-yang shading. And what does it mean to be orthogonally connected for all cells in a region, which are all shaded cells and all unshaded cells? It means you can go from any cell in that region to any other cell in the region just by going through edges, all while staying within the region. So for example, to get from here to here, you just go along these edges this way, and you will be able to stay within the region, all the while doing that to get to here. This would not be a valid example of a shading, because to get from this cell to any cell in the shaded region, you would either have to go through a corner or go outside the region through an edge to do so, to connect. And then it would also break the unshaded cells into separate regions, right? For the same reason. You would have to go from these cells to these cells by going through a corner or going through an edge through the shaded region, which is not allowed. And also, no 2x2 area can be entirely shaded or unshaded. So this is not a valid example of a yin-yang shading because this 2x2 area is entirely unshaded, which is not allowed. And that's how yin-yang works. We also have sandwich, where clues outside the grid give the sum of the digits strictly between the 1 and the 9 in the respective row or column. The full sandwich must be shaded if a sandwich clue is given. Wait, what? Okay. So that means the 1 and the 9 must be shaded, and all digits in between the sandwich must also be shaded. Okay, that's interesting. So if a sandwich clue is given, right, so not all rows and columns have a sandwich clues, but if a sandwich clue is given, all this, and we don't have a 6, then the full sandwich must be shaded. We don't have the negative constraint there, so we don't necessarily have that everything but the shaded cells everything but the sandwich is shaded. But we do have to have the sandwich itself and the digits inside of it. So the 1 and 9 are the crusts, and the digits in between, which add up to the sum, must all be shaded in that row or column. So for example, in column 2, we have a 0, so that means just the 1 and the 9 have to be shaded. There could be other shadings there, but we know specifically the 1 and the 9 have to be shaded. Say we had a 1, 9 here and a 4, 6 in between the 1, 9, right? So say we had 1 here and 9 here. Then and 4 and 6, then all of these digits, which, it's 14. Never mind, that doesn't add up. 6 and 8. So we had 6 and 8 here. That means the 1, 6, 8, 9 would have to be all shaded, right? Because that's the entire sandwich. It could be other things that are shaded. We don't know. But we know that the sandwich itself, including the 1 and the 9, have to be shaded. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm gonna get... I can't speak. I'm not going to be able to speak. I'm going to get started. Let's go. Okay. So, the digits that can add up to, that can be in between 1 and 9, can be 2 through 8, which adds up to 35. And row 9 and column 9 both add up to 35. So therefore, they must be 1 on the outside and a 9 on the other side. And these are all shaded because all sandwiches are shaded. Since this is a 2x2 area with 3 blues, this cannot, or 3 shaded, this cannot be shaded. So this is unshaded. Between the 1 here in column 1 and the 9 in the row, where can it be? It has to be, to add up to 10, well, we know the shading has to be at least 2 digits, right? Because at minimum, you have, at maximum for a single digit, it's 8. So this has to be 2 shaded plus the 9 at least. So these are all shaded. Same with these. These must be 3 cells because 7 and 8 at most add up to 15. So 3 cells and then a 9. So this is unshaded here. This is unshaded here. And can this ever be 3 cells here to add up to 10? I think the answer with this being 3 is no. So you could have 2, 3, 5 adding up to 10 as 3 unique digits, but that's it, right? To add up to 10. And since we can't have a 3 in this column, so this must be 2 digits adding up to 10. So this is 9. These are 2 digits, and so cannot be 3, 7, cannot be 4, 6. It has to be 2, 8 as a pair. That means the remaining digits in the column have to be 4, 5, 6, 7. This can't be 7 because of 7 in the row. 4, 5, 6, 7 can be next to 3 through 8, but we can't have 3 or 4 here because of 3 in the row and 4 in the column. So this is 5, 6, 7, 8. 3 can be consecutive with 2 or 4. Here we have to have 1 and 9 next to each other. Well, 9 cannot be here or here because this is unshaded. 9 can't be here. Where is the 9? It has to be... it cannot be here because that would be too many digits that are shaded because this adds up to 20 only. This is 3. Therefore, 35 minus 3 would be in between if this were 9. So 9 has to be one of these 2 digits here. One of these 2 digits is a 9 here. So 9 must be with 1. 1 can't be here, so this can't be 9, 1 here. This could be 9, 1. So one of these 3 has to be a 1. So this has to be 1 or 9 guaranteed, right? You cannot have the 9 here. It's too, it doesn't add up to the sandwich correctly if it is. And 1 can't be here because of 1 in the row. So this is 9 or 1. Therefore, where is the 9 in row 1? Cannot be here because of a 9 in the box. Can't be here because that only adds up to 0. So 9 has to be one of these 2 digits here. Again, we could have 1 here or here. So this, if this is 9, this is 1. If this is not 9, this is obviously 9. So this is guaranteed to be 1 or 9 and is part of the sandwich and shaded. And it must be either here or here. 9 is one of these 2. How many digits can add up to 17? You could have 4. Remaining digits in box 7 are 3, 5, 6, 7, 9. This can't be 9, obviously. This can't be 9. So those are there. One of these is guaranteed to be 1 or 9. So therefore, we have at least 2 digits with it and a third shaded. Oh, that's interesting. One of these is guaranteed to be 9. Well, 9 could be here. Okay. Hmm. Here we have 8 outside the shading, outside the sandwich. So 35 minus 8 is 27. That means the other digits outside the sandwich have to be 5 or less. It must add up to 5, but it could be up to 2, 3. So this has to be 2, 3, 4, 5, because it cannot be 1 or 9 here. You're only having 2 digits actually add up to 9 or 5, right? Outside. We know this is outside. We know at least one of these is outside because neither of these could be 1 or 9. And to add up outside, it adds up to 13, which is 35 minus 22. We have 8 here. You can only have 2 digits at most here. So one of these digits has to be the crust. So it must be 1. And one of these 2 digits must be the crust. It must be 9. And again, this is outside, so we only have one more digit that can be outside. So this is 9 or 1. This is guaranteed to be 9 as one of these digits. One of these is 1. Okay. One of these is 9. This is 1 here. That means these are all 9. One of these can be 9. One of these can be 1. But all of these are in the sandwich. So these are all in the sandwich here. That's interesting. If this is green, it has to exit out somewhere. But we could have 2 greens here, and then that would satisfy the 2 by 2 areas here. So that's not helpful right now. Okay, this is 14 again. So we know that this is shaded. One of these is 9. So because one of the... Okay, so this is guaranteed to be shaded. You have... If this is 9, you have at least 3 cells that must be shaded. So this must be shaded. So either it could be shaded here, 9, 1, 2, 3, right? Because 2 digits between a sandwich must be as at most 7 plus 8, which is 15. So you're guaranteed 3 shaded. So it could be 9 here with 3 shaded. This is also shaded then. So either 9's here or 9's here. If 9 is here, these 3 are shaded, and you could have a 1 there as a crust. Or this is 9, which forces all of these to be shaded, and that's 1 or 9. So since this is a 2 by 2 area that has all shaded, this cannot be shaded. And this cannot be shaded because 2 by 2 area that's all shaded so far. So this cannot be 1. Therefore, this is a 1-9 pair here. So this is a 1-9 pair, which eliminates 1 and 9 in the rest of the box. Therefore, this cannot be 1 or 9 here at all. So this has to be the crust, and this must be 9. So this is 9 and is shaded. Remember, we have to have 3 digits in between to add up to 17. This is 1. This is not 9 here. Green has to go out, so it has to connect It has to go out this way to be orthogonally connected to the rest of the greens. And then it must exit out this way, so then this must be at least green. This is a 2 by 2 area that is green, so this can't be green here. This is blue. This is 1 and 9, so that's shaded. This 2 by 2 area is all shaded, so this can't be shaded here. This must exit out and connect. The green has to connect out here, so it must connect to here and here. This is a 2 by 2 area that's all unshaded, so this must be shaded here. Green still has to connect, so this is green there. This is 2 by 2 area that's all shaded with 3 shaded, so this is unshaded. Okay, between here is 17. We're not sure where that is. This could be 1 or 9. We don't know. 1 cannot be here, and 1 cannot be here. 1 always must be shaded, so this must be 1 here. So this is 1, this is 9. Right, so none of these can be shaded. So 1 can't be there. And 1 can't be here because of 1 in the box, and these are unshaded, so 1 can't be there, so this must be 1. Therefore, this can't be 9 here. This is guaranteed to be a 9 here, and is shaded. It must shade all for the sandwich. If 1 were here, that would block the green from being an orthogonally connected region, so 1 has to be here. And then this can't be 1. This is 2 and 3 outside, adding up to 5. With the 8, that's 13 outside of the sandwich. So this is 2 and 3 as a pair, which eliminates 2 and 3 in the rest of the column. This can't be 2. This is 4. The green has to connect as shading, as a region, so that has to go there and exit out this way. Okay. So if 9 were here, this would have to all be shaded for 2 cells, but this can't, so this cannot be 9 here, which means this is 9 here. So 20 is inside the sandwich here, and 15 is outside the sandwich. Okay. This must connect out here, so this is green. This has to be 1, because 1 cannot be on an unshaded cell. So this is 1, which makes this a 6-8 pair. So this is 6 and 8. If 8 were here, it's consecutive only with 7 or 9, but we have a 7 in the column and a 9 in the column. So this cannot be 8. This is 6, which must be consecutive with 5. That forces this to be 8 here. This is not 6 here, because of 6 in the row. This can't be 5. This is 1, so then 4, there must be at least a sandwich here. And we can't have an 8, so that's at least 3 digits. And then we need a 9. The 9 cannot be here, so 9 has to be here. So then this is part of the sandwich and is shaded. The green has to orthogonally connect, so then these are all green. Okay, so now we can try to satisfy the sandwiches. So we have 2 and 3 here, therefore that leaves 5, 6, and 7 remaining in the sandwich. 4, 5, 6, 7 all add up to 22. So this can't be 7, no 6. 15. So no 3 and no 7 and no 8 in the sandwich. That means it's at most 4, 5, 6, which adds up to exactly 15. So this is 4, 5, 6, which eliminates 4, 5, 6 in the rest of the column. So that leaves, what, 2, 3, and 7? 2, 3, 7, 2, 3, 7, no 3 here because of 3 in the row. In the rest of the box is 1, 2, and 1, 2, 8, 9. 9 cannot be here or here, so 9 has to be here. We have 1, 2, and 8. We don't have any restrictions on that right now. We have a 4, 5, 6 triplet in row 4, which eliminates 4, 5, 6 in the rest of the row. So we have 2, 3, and 8 left. 4 eliminates 4 here. This cannot be 5 and 6 because that would eliminate all possibilities for this cell here. So no 5 here. So we're guaranteed a 7 in one of these cells. We don't know which. Okay. Remaining digits in column 4. We have 1, 2, 3, 4, and 8. This can't be 1 or 4 because of 1 or 4. None of these can be 8. So that means 8 in column 4 has to be one of these two cells, so this can't be 8 here. 8 can't be here. What are the remaining digits in box 2? 2, 3, 4, 7, 8. Obviously, this can't be 8. This can't be 8. Where is 8 in box 2? It has to be here. So this is 8. We're guaranteed this cannot be 3. So where's the 3 in box 2? It has to be here. So this is 3, which eliminates 3 here. Okay. If this were 2, 7 as a pair, that would mean this is 17, so this would have to be 3, but we already have the 3 in the row. So this cannot be 2 and 7 as a pair. Therefore, this must be 4 here, which means this cannot be 4 here. This is 12. 12 plus 7 plus 1 adds up to 20. But we already have that can't be because 1 can't be inside the sandwich. So this must be 2, which makes this not 2, that's 7. 2 eliminates 2 in the rest of the column, so this is 7. And this must be 2, 4, 6, 8, adding up to 20. This is 5, 7 remaining here, which eliminates 5, 7 in the rest of the box. So this can't be 5 or 7, it's 4. This can't be 4 or 7, it's 6. That leaves this as a 2. This can't be 4 or 6, it's 5. This can't be 6, it's 7. Which is consecutive with either 6 or 8. So that works there. 5 eliminates 5 here. So it's 6. This can't be 6 here or 5. So that's 4, which eliminates 4 here. There's no 6 here. We have a 2 that's outside and an 8. So 35 minus 17 is 18. So the digits outside must add up to 18. And if we take the minimum, that's 3, 5, 2, 8, which adds up to 18. So it must be the minimum. So then this is 5, 3. This can't be 3 or 5. It's 6 or 7. This can't be 3. So one of these two is 5. This 5 eliminates 5 here. So that's 7. That leaves 4, 6, and 7 remaining in column 3, which does add up to 17. This can't be 4, so this is 6 or 7. Cannot be 7, so that's 6. So this is 6, 4, and 7 to add up to 17. Therefore, the 6 eliminates 6 here. This is 8. It also eliminates 6 here, so it's 5, which means this can't be 5. That's 6. 8 eliminates 8 here. So where's the 8 in column 4? It has to be here. Okay, so this can't be 8. This is a 2, 3 pair then. No 7 in either of these spots. Because it's 7 in the box. 8's one of these two. Okay, remaining digits in row 2. We have 4 and 7. Oh, 7 eliminates 7 here, so this is 5. That eliminates 5 here, so that's 7. 1 can't be here because of 1 in the row. This can't be 3. This 3 eliminates 3 here. So that's 2 and 3. 2 eliminates 2 here, so it's 4. This can't be 4 or 3. Well, where's the 3 in column 4? It must be here. Okay, remaining digits in row 2, 4 and 7. Oops. We don't know which is which. And we have 2 and 3 in row 3. Let's just check. I think we should have everything done then, right? Sandwiches. 2, 4, 6, 8 adds up to 20. 6 and 8 add up to 14. These are definitely adding up to 35. So are these. 4, 5, 6, 7 adds up to 22. 4, 7 is 11. 5, 6 is 11. 4, 5, 6 adds up to 15. Nothing between 0. 2, 8 adds up to 10. And 6, 4, 7 adds up to 17. So we're done with all the sandwich stuff. So it's basically just normal Sudoku. Okay. We have 1, 2, and 9 remaining in row 5. This can't be 1 or 9 because of 1 or 9 in the column, so this is 2, which makes this not 2. This is 1, which makes this not 1. That's 2. This has to be 9 left. 2 eliminates 2 here, so that's 3, which makes this 2. 1 eliminates 1 here, so that's 2, which makes this not 2, so that's 8 and 2 there. Neither of these can be 2. 2 eliminates 2 here, so it's 3, which makes this 2. This can't be 2 or 3, it's 8. This can't be 2 or 8, it's 3. We have 1 and 5 remaining in row 6. This can't be 1 because of 1 in the column, so this is 5, that's 1. We have in column 6, 1, 5, 6 remaining. This can't be 1, so this is 5 or 6, which leaves this as a 7. That eliminates 7 here, so it's 4 and 7. So we have 1, 5, or 6 here. 1 cannot be here, 1 cannot be here, so 1 is here. That leaves the remaining digits in column 9 as 4 and 6. 4 cannot be here because of 4 in the row, so this is 6, which makes this 4. 6 eliminates 6 here, so it's 5 and 6. It eliminates 6 here, so it's 5 and 6. That leaves us as 5 and this as 8. And that's a solution. Pretty cool, actually. I like that. It's very simple shading rules here. And I hope basically this made sense for those of you who are not used to yin-yang shading. We didn't even have to delve into some of the intuitions that you have for yin-yang shading. It's just basically using straightforward. The green cells have to all be orthogonally connected, and the blue cells have to be orthogonally connected. But since we were really restricted on the blue cells, or restrictive on the blue cells, the green cells had to go a certain path, right? And that also limited where ones could be, so that limited where the sandwiches could be also. And it was very nice. It was a very nice interplay between those two rule sets. And I hope you enjoyed that interplay, and I'll see you next time on Frank Puzzles. Take care.